Okay, section 8.6, quadratics and graphs. If you have graph paper, I would recommend using it. What we're going to look at today is how to graph some different quadratic equations and what shape does a quadratic equation make. Hopefully you are saying parabola. So we'll start with the basic f of x equals x squared. So the first thing we can do is we can always make a t-table. Now eventually, I won't be recommending this, but all else fails, make a t-table. It's worth getting the answer right. I pick some negatives, 0, and some positives just to make everything nice and well-rounded. -3 quantity squared is 9, -2 squared is 4, -1 squared is 1, 0 squared 0, 1, 4, and 9. They repeat. Okay, so we go ahead and plot this. -3, up 9, 1, 2, 3. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. There is our nice little perfect happy parabola. So, here's some information. This little point here that I'm pointing to is called the vertex. And the vertex is the absolute highest or absolute lowest point of a graph. It's also called the max or the min. In this case, it is a min because it's the bottom. It's the lowest point the graph goes. If the parabola were upside down, it would be called a max. What's the vertex of this point? Of this parabola? It is 0, 0. That's where the vertex lies, is 0, 0. Now, if I were to fold my paper in half along this vertical axis, I could create what's called an axis of symmetry. Parabolas are symmetrical, meaning there is a vertical line that I could fold and have one half of the parabola lie on top of the other half. So, the equation of this axis of symmetry in this case since it's a vertical line, it's x equals 0. That is the same as the y-axis. It is x equals 0. So, one thing to note in terms of ax squared, if this coefficient in front of your x squared, the absolute value of that is greater than 1, then your parabola narrows or is narrower. And if it's less than 1, your parabola widens. So that will tell you how narrow or wide it is. So now, if I go ahead and look at a couple other graphs, I would recommend color coding them. So pause now if you need to grab some colors. But we do see that f of x equals 1/2 x squared. So my pink graph is going to be 1/2 x squared. And so what that does is if I look at 1/2, that is less than 1. So it does tell me down here I'm going to have a wider graph. And if I go ahead and plot some points, I'm just going to extend my t-table here with my 1/2 x squared values. And you'll see if I plug in -3, I have -3 squared is 9, and half of 9 is 9 halves. -2 squared is 4, half of 4 is 2. We have half of 1 is 1/2, half of 0 is 0, and 1/2, 2, and 9 halves. And again, these are always going to be symmetrical. These will match up with those if you do the same x values that I chose. So negative 2, 2 is a point. 2, 2 is a point. So you can see with that sketch that yes, that is wider than the original. Now, if I've got one more I want to look at, f of x equals 2x squared. So 2x squared will be negative 3 squared is 9, and 9 times 2 is 18. Negative 2 squared is 4. 4 times 2 is 8. Negative 1 squared is 1. 1 times 2 is 2. 0. And then again 2, 8, and 18. We'll repeat. So 0, 0. And then 1, 2, over 1, up 2. Back 1, up 2. And as you see, A here is greater than 1, and it is a narrower graph. The other thing to notice that if A is negative, then the parabola opens down. You might want to write that down. So if I have negative x squared, then it is symmetrical to the original black graph over the x-axis. And it looks something like that. And you can make another t-table if you'd like. Okay, so make sure you get all that information. I know it looks a little crazy, but let's go ahead and try one. F of x equals the quantity x minus 3 squared. So the things I'm going to ask you, does it open up or down? Well, the opens up or down is A, and A is out in front of this whole set of parentheses if there are any. And it's positive, so it opens up. The vertex, all those other ones was 0, 0, but in this case, it is finally shifted, and the x value is 3, and the y value is 0. The x value is the opposite of what's inside these parentheses, and the y value is whatever is out here. So in this case, it's a plus 0, so that's where you get your plus 0. Not necessary to write, but that's where the y value comes from. So go ahead and sketch it really quickly. There's your vertex at 3, 0. And you can use symmetry to graph. And the quick graphing method of normal parabolas that aren't any wider or narrower is you can go over 1, up 1, over 1, up 1, and then over 1 more, up 2. So up 2, over 1, up 2. Excuse me, 4. Yeah, because they're squares. Over 1, up 1, and over 1, up 4. So it's that same as that original parabola, but shifted over to the right 3 units. So the generic formula is A times the quantity x minus h squared plus k. Now A tells us how wide or narrow the graph is going to be, and it also tells you if it opens up or down, depending on if it's positive or negative. Now H tells you the left-right shift of the vertex, and it's the opposite the way you would think. So I write opposite in parentheses there because, like we saw in this example, it was minus 3, so it moved to the positive 3. We thought it would go negative, but it goes positive because it's really x minus positive 3, and positive is the h value. That 3 is the h value. The minus stays there. So if it's x plus 3, it's x minus negative 3, which would give you a vertex of negative 3. And K is our easy one. It tells you the up-down shift of the vertex. And so here the vertex is HK. So this is huge. All right. Number 3, y equals negative 2 times the quantity x plus 3 squared plus 5. This opens down because of the negative, and the vertex is opposite of this sign, so this is a positive 3, so it'll be negative 3, regular up 5. So we know it opens down. Our vertex is negative 3, 5. And now we can always plug another point in as well. We know this is at negative 3. So if we plug even 0 in, we can see what happens. 0 plus 3 is 3. 3 squared is 9. Times negative 2 is negative 18, plus 5 is negative 13. So at 0, it's going to be way down somewhere in here at negative 13. So you can see it's going pretty narrow. It's going down very fast, and that's what that 2 tells us. It was narrower as opposed to wider. But we can also plug in this point negative 2 and see where we are right next to the vertex. Negative. So I'm going to go ahead and do that. Negative 2 plus 3 is 1. 1 squared is 1. Negative 2 times 1 is negative 2, plus 5 is 3. So there is a point at negative 2, 3, which is there. And if there's a point at negative 2, 3, and the vertex is negative 3, then at negative 4, it's also at a height of 3 due to symmetry alone. And that is enough to get a rough drawing of your parabola. And that's what you'll be expected to do. Lots of matching on Math Excel. So if I were you and want a matching, I'd start first here. Does it open up or down? Eliminate all choices that aren't what you want, because it's very easy to tell. Then check the vertex. And before you've done any math, you may have eliminated all the wrong answers. Here's your last one to try. Y equals 1/2 times the quantity x minus 3 squared plus 6. So I want to know, does it open up or down? I want to know the vertex, and I want to see a quick graph of this parabola. And again, this is what I will be checking in class. And that is all.